Salam everybody, welcome to Physics with Noshir and we're discussing this question. So the two conditions are no resultant force, no resultant torque. Part B, you've got these three coplanar forces acting on a body that is in equilibrium. Now remember, whenever your forces are acting in equilibrium, then they will always make a closed triangle. What do we mean by a closed triangle? We mean that if you make a circle inside, for example, if you make a clockwise or an anti-clockwise circle inside, all of the forces will follow this circle. Like this force is pointing down, and so is the circle because we made the circle this way. Similarly, this force is going here, and so is the circle, and this force is going here, and so is the circle. So all of them are following the circle, and if they're all following the circle, you could say F1 plus F2 plus F3 should be equal to 0. And if these forces add up to 0, that means that it is in equilibrium. And similarly, you could also make an anti-clockwise circle inside, and you'll get the same results because all of these forces will be negative. You can take the negative and divide it on that side, and you give the same answer. So each force is represented by an arrow in magnitude and direction as shown. And then you'll say that how do you know it's in equilibrium? Because the triangle is closed. If they're closed, like I said, they'll be following the circle. But don't write that they should be following the circle because that's not a technical answer. The technical answer is that the triangle should be closed. Now this is what your triangle should look like. When you draw it, first your 7 Newton will be pointing downwards. Then you will make T2, which was pointing this way with an angle of 50 degrees to the vertical, and make it as long as possible. And then you will put your protractor here, measure 35 degrees, and draw your line backwards. Wherever these two lines intersect, this is the triangle that you needed. Now, if you want to draw it with the ruler, you can also draw it with the ruler. You could take the scale to be 1 Newton to 1 centimeter. So this will be 7 centimeters. You will put your protractor here, measure a 50-degree angle this way, and make your line as long as possible. Then measure the 35-degree angle from the other edge of the 7 Newton vector or the 7 centimeter line and draw your line backwards. But remember, because in the question T1 was pointing this way, that is why T1 must be pointing that way. Don't make T1 point downwards. T2 was pointing this way, so you can see T2 is pointing that way. Now, once you've drawn the vector triangle, then you just need to take the sine ratio. So sine 95 over 7 should be equal to sine 35 over T2 should be equal to sine 50 over T1. And now if your question is why did I take the angle of 35 degrees from here, whereas in the question they actually say that the 35-degree angle should be here, well, the reason for that is it'll be very difficult for me to find out where that 35-degree angle should be so that when I make this line, it should literally hit this point. There's a chance if I make the line somewhere else, for example, because I don't know where to make this vertical line, right? If I make it over here, maybe it goes up. If I make it over here, maybe it goes down. How would I be able to find without losing too much time? I know that if this angle is 35 degrees, then this is some alternate angle. So if this is 35, then this will also be 35. So this is easier because I already know what the length of this line is and I know exactly what this point is. So I'll just put my protractor on this line and measure that 35-degree angle. This will be equal to this, which is the same as this one. So when you find out your answer should be 5.4 and 4.0. And now if the two ropes become horizontal, then the forces in the strings would be horizontal and there will be no vertical force to support the weight. The force applied must be directly proportional to the extension that is produced. That is Hooke's law, F proportional to E. And you know when you open it, you get F is equals to K times E. Now, if they ask you to find out what the spring constant is, you will just take the gradient of this line, or you could simply use these coordinates because the other coordinate is 0, 0, and you will get the spring constant. So I've taken 40 millimeters and that gives me 50 Newton force. So I've done that and found the spring constant to be 1250. Remember to convert the millimeters to meters. That's why you see the 10 to the power minus 3. Now the work done is the area under the graph. Remember this. And they're asking for the work done compressing the spring by 36 mm. So go to 36, make a vertical line, and you have to find the area of this triangle. So half into base into height. The height is going to be 45. Again, do not forget to convert your millimeters to meters, which I've done here. So you'll get 0.81 joules. Now you're using that spring to launch this ball, and they're saying that the spring is compressed by 36 mm. That means that the energy in the spring is 0.81 joules. Now that energy converts to kinetic energy. So you put half mv squared. The mass is 25 grams as given in the question. So convert that to kgs, and the speed would be 8 meters per second. Next part says determine the compression for the ball to leave with twice the speed. Half kx squared, which is elastic potential energy, should be equal to half mv squared. This is one way of doing it. Now you know half k and half m are constant, so x squared should be proportional to v squared. You can take an under root on both sides, so x is proportional to v. Now, if two things have a direct relation, you can write them as x1 over v1 should be equal to x2 over v2. Now, first time your extension was 36 and the speed was 8, which you found out. Now they're saying if I double the speed, so v2 is doubled, what will be your new extension? It will be 72. Or what you could do is you could just find out what the kinetic energy is with half mv square. Use the same mass, just use 16 square. You will find out what this energy is. Use this energy in half kx squared, and you have the spring constant. You can find x. Again, x will turn out to be 72. And in the last part, they're saying determine this ratio of maximum height in 1 over maximum height in 2. Again, half kx squared should be equal to mgh. Half k and mg are constant, so x squared should be proportional to h. That gives me x1 square over h1 square because I have a square over here. So x1 square over h1 should be equal to x2 square over h2. And if somebody does not understand this, please open the proportionality. You'll get x squared is equals to k times h. So the constant will be x squared over h. And whenever you have this as a constant, then you can easily make your 1, 1, 2, 2 equation. You can say this is 1, 1, and then you can even put it equal to 2, 2. So x1 square over h1 should be equals to x2 square over h2. And now your x1 was 36, x2 was 72. Do not forget the squares on top and don't cancel them out because they don't cancel like that. So 36 square over 72 square, your answer will be 0.25. The sum of EMFs in a loop is equal to the sum of potential differences in that loop. What is this law based on? Law of conservation of energy. And now they've given you this circuit. And in this circuit, they're saying that there is no current going in this cell, going through this cell. You have adjusted this jockey and this variable resistor in a way that there's no current flowing here. So whatever current I is coming, it is going through this wire and straight back up. So what does that tell you? This is a series circuit and the current is flowing through this entire wire XY, this variable resistor and this internal resistance. So please apply your Kirchhoff's law because you know the EMF. All you need to do is you need to say that the EMF will be equal to IRs on the other side. Why do you say IRs? Because EMF is equals to the sum of potential differences in this loop. So how many IRs do you have? You'll have an IR over here. You will have an IR over here. You will have an IR over here. Add them. That should be equal to 2 volts. So that's what we've done in the first part. So the EMF should be equal to IRs. 4 plus 0.5 plus 2.5. You're given the values of all of these resistances. Variable resistance 2.5. Internal was 0.5. And the distance of the wire was 4. So the current that you get is 0.286. Next part says, what is the potential difference across the length of wire XJ? Now, if you notice, XJ's length was not 1 meter. Wire XJ had a length of 0.9 meters, whereas the entire length was 1 meter. Now, 1 meter represented 4 ohms. So what is 0.9 meter representing? Just multiply, cross like that, and you will get what the value of X is. Because you know resistance is proportional to length, that is why we're doing this. So the resistance of XJ turns out to be 3.6 ohms. Now they're wanting you to calculate what is the potential difference across that length. So what is the current going through XJ? The current was 0.286 because the current in the wire was 0.286. So multiply and you'll get 1.02 volts. What is the EMF E? Let's go back to the picture. So XJ's voltage is 1.02 volts between X and J. And we're saying that there is no current flowing in this battery. Why? Because this voltage must be the same as this EMF. There's no difference in the voltages. That's why current is not flowing. If there was a difference, for example, if this was 2 volts and this was 1.02, a current would have flowed in this part. But why is a current not coming out? Because current needs the potential difference and there is none. So the EMF of the cell is also going to be 1.02 volts. And that is your answer over here. And why do you not need the value of the internal resistance? The reason is there is no current, hence there is no potential difference across the internal resistance. So you don't need the value of the internal resistance. The value of the internal resistance is always needed only and only when they give you the current flowing in that circuit. So like we had this current here, so I could not ignore the 0.5 because it's a part of the circuit and there will be a voltage drop in this internal resistance. But if there is no current, then there will be no voltage drop. Hence, whatever voltage you're getting here will be the EMF of the source. Now, this is a question on the double slit experiment. You should know X is equals to lambda D over A, where X is your fringe separation. Fringe separation is the distance between any two consecutive bright or any two consecutive dark. Lambda is wavelength. D is the distance between the double slit and the screen. This distance. And A is your slit separation. Remember this formula will not be given to you, and you will have a lot of questions on this in paper 1, paper 2. Now, why one laser and two slits are used? Why? Because for interference, you need coherent sources. That is why one laser is used. One laser produces two coherent sources. How? Because when light from this laser reaches the two slits, then from the slits, diffraction happens. So this happens from the first slit, this happens from the second slit, and you can see that the waves are overlapping, hence you will have an interference pattern. Now, based on that interference pattern, here you have bright fringes and dark fringes. Remember, bright fringes are formed when a crest overlaps with a crest. A dark fringe is formed when a crest overlaps with a trough. Remember that. So if a crest is overlapping with a crest, what is the phase difference between two crests? The answer is 0 degrees. But what is the phase difference between a crest and a trough? The answer is 180 degrees. What is the principle of superposition? When two or more waves meet, the resultant displacement is the sum of the individual displacements. Use this position to explain why do you see a dark fringe? Because a crest is on a trough. Now here they've given you that the distance CP is 2.3. You can see that is between a bright and a dark fringe. But fringe separation is always between two consecutive bright or two consecutive dark. That is why I've doubled the distance. So 2.3 into 2 into 10 is power minus 3. So just posting this here for your reference, they've given you this distance as 2.3, but you know that X is from here to here. So you have to double the distance, is equals to lambda into 1.8 divided by 0.25 into 10 to the minus 3. You will get 0.639 10 to the minus 6, which is 639 nanometers. GPE is the energy possessed by a mass by virtue of its position in a gravitational field. Kinetic energy is the energy possessed by a mass by virtue of its motion. Now you have this question of a projectile. First question is, what is the initial kinetic energy? Remember, for kinetic energy, you're always using the overall speed. The overall speed is 30. And the answer that you get is 180 joules. But when they ask you to find out what is the maximum height, now you have to use a component because they're asking you to move in a particular direction, which is vertical. So you will say 30 sine 45 is my vertical component. And if you notice, 30 cos 45 will be your horizontal component. Guys, when you will reach the top, your vertical speed will become 0. However, your horizontal speed will remain the same as 30 cos 45. That means that at the highest point, will you still have some kinetic energy? Yes or no? The answer is yes. Because your ball is not going to drop down, it's going to go forward. It'll be less because if you're going up, you're gaining gravitational potential energy, you're losing kinetic energy, but it will not be 0. Never confuse it with the case when a ball is thrown straight up. If a ball is thrown straight up, then at the highest point, your kinetic energy should be 0. But when you throw it in a projectile, then at the highest point, it's not 0 because you will still have some speed at the top. So you will use 2as is equals to v square minus u square to find out what this height is. 2as is equals to v square minus u square. Your vertical acceleration is minus g. Why is it minus g? Because when I've taken the upward direction to be positive, because I wrote plus 30 sine 45 over here. I simply wrote 30 sine 45. That means I'm taking it to be positive. Gravity is always pointing down, so it's negative. And therefore, minus g, which is minus 9.81 into h is equals to 0 square, because you know your final vertical speed at the top is 0. Remember, you have to use only the vertical components. Do not mix the vertical and horizontal. ये ना हो कि आप कहो जी final speed should be 30 cos 45 over here. Why? You're using an equation of motion. Equation of motions में सिर्फ और सिर्फ one component can be used at one point. You cannot use both components. You can't say 2AV into SH is equals to VV square minus UH square. That's completely wrong. Either the whole equation has to be in the horizontals or the entire equation has to be in the verticals. So 2 into minus g into h is equals to, now when you reach the top, your final vertical speed is 0. Initial vertical speed is 30 sine 45 whole square. Minus minus will get cancelled. The height that you will get is 22.9 or 23 meters. To find the gravitational potential energy, use mgh. You were given the mass 400 grams, convert that to kg, 9.81 to height, you get 90 joules. Kinetic energy of the ball at maximum height. Please don't write 0 because you still have some horizontal speed, and that also turns out to be 90. Why the kinetic energy is not 0? Because the horizontal component of velocity is not 0 at the highest point. Alpha particle is a helium nucleus consisting of 2 protons and 2 neutrons. What is the approximate range? 2 to 3 centimeters. So I've written 2 centimeters. Now, they want you to find out what is 8.5 into 10 to the minus 13 joules in electron volts. So 1 electron volt is 1.6 into 10 to the minus 19 joules. A single alpha particle has this energy, 8.5 into 10 to the minus 13 joules. So first find out what is this energy in electron volts. And how do you do that? You can divide 8.5 into 10 to the minus 13 by 1.6 into 10 to the minus 19. Why? Because 1 electron volt is equivalent to this, then x electron volts should be equivalent to this. And then you can just cross multiply. 1 into 8.5 into 10 to the minus 13 should be equals to x into 1.6 into 10 to the minus 19. And you will find out the value of x, where x will be in electron volts. So the x value that you get is 5312500, but they asked you to do it in mega electron volts, so you need to divide this by 10 raised to the power 6, and you'll get 5.3 MeV. Now, to 2SF, the number of ion pairs that are produced as alpha particles are stopped in air. Now, the energy that you need to produce one ion pair is 31 electron volts. So one ion pair requires 31 electron volts. How many ion pairs will you produce with this amount of energy? Again, just cross multiply. So 1 into 5.3 should be equal to 31 into x, and the value of x is 1.7 into 10 to the power 5. In the last part, they're asking you for the average number of ion pairs produced per unit length. So we said 1.7 into 10 to the power 5 ion pairs are produced. Yes. Divide that by the range that you mentioned over there, which was 2 centimeters. That was the maximum range of the alpha particle. So when you divide, you'll get 0.85 into 10 to the power 5. So your final answer will be 0.85 into 10 to the power 5 per meter. Why? Because it's per unit length. The number has no unit, so you have to mention the unit per meter. Now, in order to calculate the change in momentum, the formula is mv minus mu. But remember this, that whenever your direction is reversing of the same molecule, so same molecule goes left and then the same molecule goes right after collision from a surface, then remember this formula becomes mv plus mu. Why? Because you're dealing with a vector quantity, and if you're taking this direction as, let's say, positive, then this direction is going to be negative. And then when you'll take a difference between these two quantities, when you do positive minus negative, then you will get positive plus positive. So that's why I always say that whenever your direction reverses, without any doubt in your head, just write mv plus mu. So the change in momentum should be mv plus mu. Now you have the mass and you have the speed, just plug in the values. So the same speed will be used twice, and multiply with the mass, you'll get 1.66 10 to the minus 23. Now, use the kinetic model to explain the pressure exerted by the gas. When a molecule collides, there is a change in momentum. The change in momentum causes a force to be exerted over this area or the surface area of the container. There are many collisions over the area which exert a pressure. It's very important to mention that there are many collisions. And the last part says what will happen if you increase the density. That means you're using more molecules per unit volume, hence there will be more collisions per unit time, hence greater pressure.